All right, hey gang. We are gonna just I'm gonna introduce a couple of problems here to you just to quickly review some of the things that we've talked about in class, and then I'm gonna let you guys go with this review. So if you have questions, as always, come and talk to me. So when I take a look at 9.6, we're talking about angles, whether they're inscribed or they're basically circumscribed on the outside, and so. And how does that play out with the intercepted arcs? So the first thing I'm going to do is I'm going to draw a couple of pictures here. The first one being an inscribed angle, and I'm just going to put in a formula here, and I'll put like maybe, okay, something like that, which tells me, if you remember the rule, the measure of angle A is going to be half the measure of the intercepted arc, which would be arc BC. Okay, I don't think I'm gonna put measure anymore on these other ones, but that's what it's gonna be. Okay, we also want to remember that if the intersection takes place inside at the central angle, okay, so if it's at the center, okay, angle A will equal arc BC. Okay, so those two are equal in measure. However, if the angle is somewhere other than the center, so maybe I'll do something like this, and I'll put A, B, C, D, and E. Remember this angle at A, I'll say angle BAC, is going to be the average of the two intercepted arcs. So here's our angle we're looking at. It's half the sum of this arc and this arc. Or as I'd like to say, the average. So if I do arc BC plus arc DE, okay, that would be the average of those two arcs, okay? We also have, if you have a tangent line to a circle, so if I go ahead and do something like this, a line tangent to a circle, okay, and then you have either a secant or a chord, maybe I'll do something like this, okay. We would know that angle BAC is going to be half the measure of that intercepted arc AC. Oh, I can put half in front of that. Half of arc AC, okay? And then the last one is if the intersection takes place outside the circle. Okay, so if I do something like this, okay, angle A will be half the difference of those two intercepted arcs. And I always do the bigger arc, so CE minus BD, okay? So that's really all, I think that's everything that we'll be covering here in this review. So if I take a look here at number 1, the first thing I'm probably going to do is I'm going to go ahead and figure out what arc JL is going to be. So if I take 360 minus 239, okay, well, that'd be 121. All right, let's see here. 1, yep, which would be 5. Yep, so 121. So this arc measure right here is 121 degrees. If I want to figure out angle K, because it's on the outside, it's going to be half the difference of those two arcs. So 239 minus 121. Okay, so if I do that calculation, give me 1 second here, I'm going to pause. Okay, had to get out my handy dandy calculator here. If I do 239 minus 121, that gives me 118 divided by 2, 59 degrees. So I know that angle K is going to be 59 degrees. Okay. All right. Another one we could look at would be angle 2, or number 2, angle L. Angle L is going to be half the measure of that intercepted arc, 120. So half of 120, which is going to give me 60 degrees. Okay. If I go down to number 4, this angle on the inside, 95 degrees, is going to be the average of the two intercepted arcs. Now it's 135 and UT. So 135 plus UT, that arc right there, okay? Now, you could do this multiple ways. I think I'm going to multiply both sides by 2. That would give me 190, gets rid of the 1/2 there, equals 135 plus UT. And then if I subtract 135 from both sides, that would give me 55 degrees. Yep, 55 degrees is UT. Okay, oops, there we go. So 55 degrees there, okay? If I go down to, like, let's say number 6, okay? Actually, you know what? Let's swap over to the back side. We can do number 6. We'll go with backside for one like number 8. Okay. For number 6 right here, we have 140 degrees here, 40 here, 40 here, and then a question mark there. If the angle's on the outside, remember, it's half the difference of those two arcs. So I'm going to do 140 minus the question mark. Okay. So if I multiply both sides by 2, I get 80. If I subtract 140, I get negative 60. I still got a negative question mark, so if I divide through by negative 1, 60 degrees will be the question mark right there. Okay? So that's what we're looking at for number 6. If I flip over to number 13 here, okay, remember this angle S is going to be, so it looks like 7x minus 2 is going to be half the measure of its intercepted arc, which is going to be 12x plus 14. Okay? So if I go ahead and distribute that 1/2, 6x plus 7, 7, and then I can go ahead, let's say we subtract 6x, and let's say we add 2, x will be 9. Now, if we're trying to find angle TSR, which is this angle right here, I can go ahead and plug in 2 right there. 7 times 2 minus 2. So 14 minus 2 is 12. 12 degrees is going to be the measure of angle TSR. Okay? So, why did I put 2? I meant to be 9 there. That's going to change a couple of things. And I thought the angle looked bigger than a 12-degree angle. So let's do 63 minus 2, which would be 61. That looks better. Okay. So again, I'm supposed to add 2 over, instead I just put 2. So, okay. Anyways, I hope that made sense to you. If you have questions, as always, come back and talk to me. But that is a quick overview of what I want you to do for this packet or this worksheet here. Good luck, and we'll see you tomorrow.